Okay, this, so the plan today is to talk a little bit about what B2B sales is. Uh, some of you might know, but I'll talk about some of the intricacies around that, what are the challenges, and then figure out how that's being done traditionally in machine learning. And then we'll go about challenges that's currently plaguing that particular field and how newer methodologies can help overcome some of the challenges that we see. Yeah. So that's me. You've already heard about me. So, okay. So this is something that when you talk to salespeople, I mean, in general, to anyone for whom the job can be threatened by automation or by machine learning, this is something that you're going to hear a lot of pushback. And go, I actually know things more than what these guys are telling, using data, things like that, right? So the question is, will machines take over the world, or is it just going to be yet another instrument like a calculator or a phone that we use, something that can help us do better? And my talk is positioned to be on that side, telling that the way the current state of art is, it will help us become better in doing things more efficiently than what we actually can do, rather than the machines taking over our stuff. Some differences between machines in general. When I tell machines, they're intelligent machines, and human beings. Human beings are very emotional, right? And then they're very inefficient. So we sleep, we eat, we do a lot of things which are inefficient for work. But then evolution has given us some advantages. We can take decisions very quickly. Many times we don't even need data to come here. Some people here, I mean, just for an example, you might have just seen the title and, oh, okay, I might like it, so I'll go and attend this talk, right? So it's not even reading the abstract, getting more data before coming here. But then machines, on the other hand, are very rational. The problem, so it is also efficient. So it can run doing monotonous work 24/7. But then it needs a lot of data to do things. Can we find a way where we can take the best of both worlds and do something? And that's what we're going to talk about today. So before that, the problem about what B2B sales is. So imagine a company that's making some hardware or software product. Taking an example of television, but it can be a security product, it can be a router, it can be a switch, it can be a computer, it could be a data center, it could be anything that you want to sell to another business. Each product has multiple variations, and you sell a suite of products. So now what the typical problem that comes to data scientists is that given your customer base and the list of customers that's present in a particular region, you want to identify customers who will buy my product, right? And so you take a specific time horizon, say next month, and I want to find customers who would be ready to buy, and I want to build a predictive model to do that. And also for those customers, I want to find products for existing customers, products that I can upsell, cross-sell products. A very typical machine learning workflow would be something like this. You have a lot of input data. Input data could be historical transactions that the customer has had with this company before. It could be things like firmographics. It's companies, what industry vertical they are in, how many employees they have, what's their budget, what's their annual revenue, information like that are all called infographics. You can have information about your competitors, how well they are doing, what kind of models they are there. Generally, a lot of third-party market research companies create these kinds of data, and they sell to companies. And then you can also have a whole bunch of customer interactions. This would fall under your social media campaigns, your marketing campaigns, and also it also deals with customer support calls, things where you would have information about customer touch with with your company. So a data scientist would take all the data, as much as you can get, and then it flows through a pipeline like this. It goes through a data engineering pipeline, so they all come from different data sources. You combine them, you create a unified view, and then you create features out of that. It gets fed into a machine learning model. You generally do a lot of machine learning models before you select one, and then the output would be something what you would predict, right? There are some things that I'm omitting. I'm going to come back to that later. But there's one thing you should know about data scientists. They love to throw the kitchen sink at everything that you give it to them. So you would have something like this. You give them a problem. They'll be like, oh, this is awesome. So I'm going to try all sorts of techniques that I have read, that's cool, that I can use to talk at the next conference. They do all sorts of stuff. The problem is, OK, so they do something, and then you'll have outputs. The typical output that is generally done in a B2B sales would be something like that. You would have, for each particular product that the company is trying to sell, for each customer, you would want to know what the propensity to buy. So this could be a probability number, or you can tell it's high, medium, low for a product, propensity to cross-sell, propensity to upsell. And then you would also tell, oh, if the customer buys from me, how much can I expect from this particular customer? So these are fairly typical outputs that you would expect when you are going to give the output to a seller. You'd give a little more than that, but these are enough dimensions. So for example, if the company has like 10,000 variations of the TV, you're going to present the predictions to the seller, and he would be like, what the hell is this, right? Because then what you're telling us that making this into production is going to be extremely hard. So you're going to take one bunch of numbers, and the data scientists are going to transform, and they would provide a different representation of the same set of deluge of numbers. And it's very difficult to make things actionable if you do something like this. This is with machine learning. So now let's come to the selling part of it. Selling is very artistic stuff, and it's also very iterative. It's more relationship-oriented. It's not like how you're buying it from e-commerce site is. This is very, very iterative. This is a very, very simplified version of it. Reality is much more complex than this, but you can think like this, right? So first, the salesperson will find some way to identify an opportunity that, OK, this particular customer might need a TV. And you would use some sort of tracking mechanism to create a pipeline. The current standard is to use Salesforce.com, but then you could use any of these ERP systems to do that. Then you would call, so at each level, there'd be multiple interactions with the client. So this is something that keeps happening all the time. And then he would ask for a quote, you would give a quote, and then he's going to come back, oh, this is expensive, we need to negotiate. So this sort of negotiations happen for a while. This particular process, this quote negotiation happens for quite some time, right? So if you've been in B2B sales, this can take anywhere between 1 quarter to 3 quarters. And if you're really good, and I've seen things where it's taken even more than that. And then finally, you would do the deal, and the order is placed, right? So things that's very important. The domain knowledge is very important, but there's a very specific reason why the salesperson is very crucial to this entire process, because he has a lot of information about the customer. So when a salesperson calls the customer, in the first few seconds, our brain kicks off the process, and we already know if the customer will buy that product in that call or not, right? But then your algorithm will only tell, OK, it has a 90% chance of buying or a 92% chance of buying. It doesn't really tell if he's going to buy in this particular call or not. It's going to go through multiple rounds of negotiation. How do we leverage information that you get instantaneously with all the models that you have built? We do two kinds of stuff, two broad ways. One is called active learning. It's called the human in the loop stuff. The other is a more futuristic version called reinforcement learning. Okay, active learning. What's active learning? I cheated a bit before when I told that the data scientists throw a kitchen sink, because it's not always that you have labeled data, right? So most of the time you have data, but you probably don't have labeled data. You don't really know what action caused something to happen, what was the output of that particular action. That's something that's very hard. That's a very expensive process, and that's not something that's really very mature and evolved. An example is something like this, that a customer is ordered for a television, so deal is placed, so that's good. But then one thing that's really important is to know if it's a replacement of an existing device, or is it in addition to what is the customer growing his base? Is he adding more televisions? Is he going to change his business? Does his business require more television? These things will impact how this particular company's sales to that kind of customers will change in the future. This can change demand, supply, because this can change supply, this can change demand, and that will change supply. There's a lot of stuff that can happen around. So you need to figure out if that's a replacement or if it's an additional stuff. If you use with existing data stores that we have looked into, there's no way to figure out. But then the executive, when calling, can ask this question, and you would have additional data points which can then be fed into the model, right? So that's how an active learning works. So you'll have some amount of labeled data set, and then you build a model using that. And then you keep querying the user every time, telling, oh, okay, do you need this, do you need that? So every time you interact with the user, you add more information to that. And that gets fed back into the model as more inputs to that particular observation, and you keep refining this process. So this is at a very high level on how active learning works. Key thing to note here is that, so there's red, there's green, and there's a bunch of points that's, we don't know what its state is, if it's red or green. So we would start with a very simple linear line, which classifies them into will buy, won't buy kind of stuff. We would take the point which is very close to the margin, and then use that as the basis to, okay, can we get more information on this particular feature or on this particular customer, and use that to improve upon the model. So maybe if this becomes red, then your line entirely shifts, right? So that's how it happens. A slightly more complex example would be something like this. You have a lot of links, and you know that some links are not labeled, and you want to figure out what the labels for it is. And every time you can either ask for the query, or you can create more models. And this goes through a few iterations before you do some more user query, you get an output, you get a better model, and then you go to the next iteration. You keep doing this until you do that. So every time you will have a model which is out in production, and you will still keep refining your process. And this is the essence of active learning. The advantages are that the feedback is instantaneous. You actually know what's currently happening. It almost invariably improves the data quality. So that's the biggest challenge when you have, think about an example of a TV, right? So generally company sales, and this is true whether you have a laptop or you have a router, it has a warranty, it has some service contract associated with it. At some point it expires, and you don't know after that if the customer is still using it or not, because the customer has gone and bought something else. Maybe the customer is using it for some other purpose. You wouldn't know that. But as you get more information, you can start to characterize, oh, okay, this kind of equipment can be used for something else. Places which the company might not even know before. This definitely improves model performance because you now need lesser amount of data than lots more of data. So you can start building models. You can start going to production and start refining stuff using more model with superior model performance. Okay, but we can do all these things, but there's still a couple more issues. One is we still don't know what all features would have to be taken to do that. And that's still manageable to some extent, but this is a very difficult stuff. When you do active learning, the question is, are you going to poke your user for more data, or you're going to get satisfied with the deal and walk away with the deal? Do you know if the customer will buy more? Should you even try selling more? So there's always a trade-off between spending more time with the customer than poking more information, getting data, and see if something else can be done, right? So that's so one paradigm that can really help in that is reinforcement learning. How does that work? So this is fairly textual, but you have a software agent, a group of software agents, and they have some reward associated with it. You want to come up with a model that can maximize the reward given the behavior that each particular agent can tell. We'll do some example to demonstrate this. So tic-tac-toe, common way to play it is you have this particular grid. I start with a circle. The computer puts a plus. I put a circle. Computer puts a plus. So now we know that if I put a